All right. Hello, everybody. It has been a while. Spring break happened, and hopefully everybody's doing all right. Um, let's see. I'm just trying to set things up because it's been a little while. Now, guys, just let me know if you can hear me all right, if you can see me, see my stuff all right, all that kind of thing, just to make sure before we get started here. And you guys can tell me in the comments how your spring break was. I can just say for myself, this was probably the least exciting spring break that I've had in a while. For obvious reasons, I just stayed at home and didn't do a whole lot. Did my taxes, which are not due this year until July because of the coronavirus and all that kind of stuff. But besides that, didn't really do a whole lot. What'd you guys do? Anything fun? Any exciting things you guys did over spring break besides watch TV and play video games or anything else? I don't know. I didn't do a whole lot. So anyway, on to the whole chemistry stuff. So let me just give you a heads up of what's going on before we jump into everything. And I'm still waiting to hear about your spring break in the comment section. But we stopped kind of halfway through this unit on acids and bases right before the break. And we're going to go ahead and continue up and finish that up. So our test for acids and bases will probably be next Tuesday. So just keep that in mind. Today, I realized that a lot of people, I don't know, were struggling with or just didn't feel like doing the other part of that assignment. And so we're going to do a little bit of a review of molarity. So maybe you guys were struggling with doing the whole calculating molarity stuff for your pH. So we're going to talk about that today. All right. So let's see. Anybody? Comments? How was your spring break? All right. Looks like nobody wants to comment. But anyway, let's just jump right into this. I'm just going to adjust this a little bit. I don't know. It's been a while. It was good. Good that your spring break was good. Did anybody do anything other than just stay home? Probably we all should have just stayed home, but I don't know if anybody did anything else. All right. So, let's see. What I want to do is I want to go through problems 1 to 4. If you guys have all seen this this worksheet, it should be up on Google Drive. You guys can see it on Google Drive. And then mine might look a little bit different from yours, just I give myself a little bit more space. And so we're going to go through 1 to 4 here together in class, and then you guys can do the backside for homework, and we'll talk about that tomorrow. All right, so still talk about acids and bases, but I want to take a little bit of time to discuss molarity in more detail. All right, yeah, all right. So we went on walks. I thought it was going to have a different place in Google, like it was going to be in the same Google Doc thing. Wait, Anna, what are you talking about? I'm not sure what you're saying. So we're still putting everything in the same place, and the schedule got all changed around, but our class is still meeting exactly the same time as always. So pretty much everything's going to be the same. Oh, you're talking about the assignment, Anna. Okay. So you thought it was going to be in a different place, but I was actually looking in the same place, and that's what happened. Okay. But you may have even done it. I don't remember whether anybody that got only partial credit, you guys can resubmit that homework. Okay. Yeah. So back when the assignment was due, so I wanted you guys to, we took 2 days to cover it. I wanted you to turn in half and then turn in the other half the next day in the same place. But very few people did that. Some people did, but very few people did that. And if you have partial credit, you can resubmit it, or you can just email it to me. Email would probably be the easiest. Anytime you don't have an assignment done on time or need to make a correction, you can just email it to me. Yeah. So you can either resubmit it to Google Drive or just email it to me. All right. So we're going to take it a little bit slow. We're going to go through molarity, and then we're going to talk more about pH tomorrow. So I know this is going to be kind of hitting the same thing over and over again. And then on Wednesday, we're going to talk about something totally new. And then probably Friday, just review. And then Yeah, Monday review and then Tuesday tests. So here we go. All right, molarity. So in order to solve any of these molarity problems, the equation for molarity is simply this: M equals N over V. Now you guys have seen this equation before, and in case you guys forgot, this N stands for moles. So that's general. In general, an N stands for moles. Now, when we're talking about molarity, that's going to be moles of the thing that's dissolved, moles of your solute. Solute being the thing dissolved. Okay? The V is going to be, of course, your volume. And it's important that this volume is in liters. All right? And so that's going to be one adjustment that you're going to need to make a whole bunch of times, that you need to turn the volume into liters when oftentimes it's going to be in milliliters. So make sure you make a note of that. That volume's got to be in liters. All right? And let's see. This is going to be the volume of the solution. Not the volume of the solvent, but the volume of the solution. They're pretty much the same, but they can be different a little bit when you have very concentrated solutions. So this is going to be the total volume of the solution, which only is going to make a difference into how we make it in the lab. But in terms of your calculations, it's going to be pretty much the same. Okay? So this is the volume of the solution in liters, and M, of course, stands for molarity. I do have a video on this. You guys can go back and check, but I'm going to go over it right now too. So whatever you like. If you want to check out that other video, I've got molarity made easy, and we're going to go over some examples right here. So we got 0.225 moles of sugar that are dissolved in water to make 500 milliliter aqueous solution. What we need to do here is just identify everything. So first of all, it says what is the molarity. So we are solving for molarity, right? We're trying to figure that out. And it's going to be this 0.225 moles. That's going to be our N. And this 500 milliliters, this is going to be our volume, but the volume must be in liters, so we need to convert that to liters. So you think about it, okay, 500 milliliters. Well, keep in mind that 1,000 milliliters is 1 liter. So 500 is going to be half of that. Or we can think about it a different way. We can say, all right, anytime you're converting from milliliters to liters, you need to take that decimal point and move it 3 spots to the left. You need to take that number and divide by 1,000. So you're going to need to do that a lot. So be able to do that fairly quickly, fairly easily. Okay, milliliters to liters is a very important type of conversion that you have to do. So we're going to take that decimal point, move it 1, 2, 3 spots to the left. So this volume is actually 0.5 liters. So what is this? This is going to be, molarity is going to be the moles of 0.225 over the volume of 0.5, and that'll get us an answer. So let's get the calculator over here. Here we go. 0.225 divided by 0.5, and there we go, 0.45. Okay? So, oops, 0.45. And our units, so this is 3 significant figures. Our units are going to be moles per liter, or we could simply use capital M. I'm going to use moles per liter as much as possible. So 0.450 moles per liter. All right, so that's your basic way to calculate molarity with your basic molarity problem, but sometimes you're not calculating molarity. Sometimes you're going to be calculating the number of moles. Sometimes you're going to be calculating volume, and sometimes, and most often, we don't actually have the value of N in the problem. We actually have to calculate it as part of the problem. So let's go ahead and do the next one, number 2, which is calcium chloride. We got calcium chloride that's dissolved in water, but it looks a little bit different. Let's see what's going on. We have how many moles. That means when it says how many moles, it means that we are calculating N. We don't know N. All right? 20 milliliters, that's going to be a volume, but once again, our volume needs to be in liters, so we need to convert that to liters. So we're going to move that decimal point 1, 2, 3 spots to the left, so that's not 0.2, but 0.02 liters. And this 2.18 M, this capital M, anytime you see that capital M, that's going to be the same as moles per liter. So you have 2.18, we call that 2.18 molar calcium chloride, or 2.18 moles per liter calcium chloride. So that's telling us our molarity, and in this case, it's going to be 2.18 moles per liter. All right, so we have V, we have capital M, but we don't have N, so we're going to solve for N. So how do we do that? We're going to use this equation, M equals N over V. And now we want to solve for N, so we're going to multiply both sides of the equation by V. So that gets us MV equals N. Okay? NV equals M. And so in general, and it doesn't matter whether it's MV or VM, this works either way. All right, so you're just multiplying the two numbers together. And you'll notice when we do this, I'm going to do it VM. You'll notice when we do this how the units are going to work out very nicely. So if I set it up, if I'm going to do N is going to be my V, so 0.02 liters, and I'm going to multiply that by the molarity. Check this out. We could just simply write 2.18 moles per liter, or what I'm going to do is 2.18 moles per liter, so we can see that the liters on top and liters on the bottom are going to cancel out. And just like what we've done for other conversions, this molarity acts as a conversion factor. The molarity is a conversion factor between your volume and your moles. And so we can use that as a conversion factor. So let's do that. It's going to be 0.2 times 2.18, and it gets us 0.0436. 0.0436. And our units, well, we know that we're solving for moles, so the units, of course, are moles. Also, we could see that here liters over liters are going to cancel out. All right, so liters over liters cancel out, and we're left with the units of moles. And so that works out both because we're solving for moles and because that's what our units are remaining after the calculation. All right, so sometimes we're solving for moles, sometimes we're solving for molarity, sometimes we're solving for volume, but in this next one, let's see, this next one we're also going to be calculating the molarity, but it's a little bit different because let's go ahead and read it. If you dissolve 10 grams of aluminum chloride in water, well, what is that? 10 grams of aluminum chloride, that's a mass, right? That doesn't fit the equation that we have. M equals N over V. Mass isn't in that equation anywhere, right? So that's our mass. And we want to make a solution with the final volume of this. And so that's our volume. And once again, we want to convert that to liters. So I'm going to move that decimal point 1, 2, 3 spots to the left. So that's 0.33 liters. And it's saying, what is the molarity? So we want to calculate your molarity, but you don't have N. So how do you do this? Well, we know how to convert mass to moles. So we're going to need to do that before we can calculate the molarity. So in order to calculate the mass, we're going to need the molar mass, and so we have 10 grams of aluminum chloride. So let's go ahead and see, well, first we need to know what in the world is the formula of aluminum chloride. Well, aluminum, normally when it's in an ionic compound, aluminum has a 3+ charge. You can see it right on the periodic table, right? So let's move this up a bit. We see aluminum, right, is right here, right? We have +1, +2, +3 for aluminum. So aluminum should have a +3 charge. And aluminum chloride is way over here. So it goes +1, +2, +3, skip the carbon column, 3 minus, 2 minus, 1 minus. That's where chlorine is. So chloride has a -1 charge, which means the formula of aluminum chloride is AlCl3, right? We just take those two numbers and flip them, and we get AlCl3. So we need to calculate what is the molar mass of aluminum chloride. And so once again, we look back at our periodic table, and we have 1 aluminum and 3 chlorines. So that's going to be, aluminum is 26.982, and we have 3 chlorines. Each chlorine is, so it's 3 times 35.453. You guys can look all these numbers up on the periodic table, right? So chlorine's 35.453. We're going to multiply that by 3 because there's 3 of them in the formula. That 3 right there. And we hit enter. All right, and so our molar mass is 133.34. 133.341 grams per mole. All right, so now that I have my molar mass, I can solve this problem because I can convert this 10 grams, that mass, to a number of moles. So I'm going to do 10 grams of aluminum chloride. And to convert it into moles, we're going to put these grams. Well, if I'm starting with grams, the grams of our molar mass needs to go on the bottom. So it's 133.341 grams. And your moles are going to go on top. So that tells us that to solve for the number of moles, it's going to be 10 divided by 133. So 10, and I'm just going to use a number in my calculator. So I'm going to go 10 and then use that number so I can answer. And that's the number of moles of aluminum chloride we have. Okay? That's a pretty nice number, right? So that's 0.075 moles. Okay? That we're just going to round that 995 up to, so make that 0.075. All right? So now that we have the moles, we can now plug that back into our molarity equation because we have the volume and we have the moles. This right here is our N value. So plugging everything into this equation, M equals N over V, and that's going to be M equals our moles of 0.075 over a volume of 0.33 liters to get a final answer of, and what I like to do is just use that number in my calculator. Now I'm dividing by 0.33, and that gives me a final answer of 0.227. 0.227 moles per liter. Okay. All right, any questions so far? So we've gone through 3 different practice problems for molarity, solving for different things, solving for molarity in a couple different situations. I now want to apply this to calculating pH. All right, so I know it's been a while, so maybe you guys remember this stuff and are really good at it, and maybe you don't. So either way, we're going to do a practice problem. We're going to solve for the pH of something. And so we're going to see how this is related to molarity, right? So for number 4, if you dissolve 10 grams of HNO3, that's nitric acid, in 350 milliliters of aqueous solution, what's the pH? In order to solve this problem, you need to calculate molarity. Why? Because our equation for pH is negative log of this, which is the negative log of whatever your acid, if this is strong acid, whatever that is. And if you remember what these brackets are, does anybody remember? Let me ask you guys right now. What in the world do these brackets mean? So negative log of H plus brackets H plus, or negative log of brackets acid. What do those brackets mean? What in the world is that? Is it the same as parentheses? No, it's not the same as parentheses. What do those brackets mean? I'll give you a hint. It's got something to do with what we're talking about today. Anybody on the chat want to tell me what the brackets mean? Brackets means molarity. Okay? So when we're solving these equations, we need to know that these brackets mean the molarity. So the molarity of your H plus, which essentially your H plus is your acid. As long as you're talking about a monoprotic strong acid, which I'm always going to be giving you guys for these kinds of problems. It'll always be monoprotic, and it's always going to be a strong acid, and so these two equations are basically the same. The pH is the negative log of your acid molarity. That's why we need to review molarity for our acids and bases. So back to this problem, how do we solve it? We know that we need the molarity of the acid in order to figure out the pH. So we have a volume, 350 milliliters. In fact, we need to make sure we convert that to liters, because if we leave it in milliliters, we will get a crazy number. It will be wrong. Okay, so we're going to take this and move it 1, 2, 3 spots to the left. So our volume is 0.35 liters. And our moles, once again, we don't know the moles. We have the mass, 10 grams. So we need to take that 10 grams and convert it to moles. But we have nitric acid, not aluminum chloride. So once again, we need to calculate some other kind of molar mass. So the molar mass of nitric acid, we need to look at the periodic table. Let's move this up. Periodic table. Nitric acid has 1 hydrogen, right? That's going to be 1.0079. It has 1 nitrogen, which is 14.007. And there are 3 oxygens. So it's 3 times your oxygen is 15.999. So nitric acid works out to be 63.012 or 0119. That's your molar mass of nitric acid. So in order to calculate the moles, we need to do our 10 grams of nitric acid divided by that molar mass of 63.012 grams. Okay? 1 mole of nitric acid has a mass of 63.012 grams. So our grams, if we start with grams, our grams need to go in the bottom. So we are dividing once again. 10 divided by that molar mass gives us 0.15, and we can go ahead and just, I'll go ahead and write it all out, 1587 moles. Okay, you don't want to round too early. That might mess up your final answer, but you can write, 0.159 moles if you want. So that's the number of moles. Now you might make a mistake right here and say, okay, I'm just going to plug the moles into this equation, but that would be wrong. Remember, the brackets do not mean moles. The brackets means molarity. So we need to convert this, or we need to calculate the molarity. So we have the moles, we have the volume, but we don't have the molarity. Molarity is the moles over the volume. So it's 0.1587 moles divided by 0.35 liters. So let's do that. Divided by 0.35. Now we have the molarity, which is 0.453 moles per liter. Okay? Almost there. One last step in this problem is we need to take this molarity and plug it into this equation. We spent a bit of time so the week before spring break, talking about logs and talking about how the pH is in a log scale. But let's go ahead and just plug it in the equation right now. So we do negative log, this is the log log, so that's a base 10 log of whatever our previous answer was. I just like to just store it in the calculator like this. It makes your answer work out to be a lot more accurate than if you type in this number here. Because if you just type in this number, you'll end up with rounding errors. It's always good to just use whatever number's in your calculator. So negative log of that. And we get this answer, 0.343. So the pH is the negative log of 0.453, which is 0.343. 3, 4, 3. Okay? And you need to include all these digits. Don't just say the pH is 0.3, okay? Because each of these digits is significant. So after the decimal point, each of these digits is significant. Before the decimal point, none of those are significant. So make sure you include at least, points, 3, so 3 digits after the decimal point. That's going to be pretty important when you're calculating pH. I know you guys are used to just saying, oh, it's a pH of 1, the pH of 2, pH of 3, just to rounding it off the whole number. We can't do this. We have to have a little bit more or a lot more precision by including these digits over here. All right, so that's our pH. It's a fairly low pH. And let me just ask you guys, is this very acidic, very basic, or kind of neutral? What kind of pH does that look like? In your opinion, is this something that's very acidic, very basic, or somewhat neutral? What do you guys think? What do you guys think? Just seeing, you guys still with me? So there's 8 of you guys. Very acidic is correct. Yes, that's very acidic. Anything less than a pH of 1 is very, very acidic. And we're not surprised because we have a solution of nitric acid. So that makes sense, right? So a very low pH. So that's very, very acidic. Very far away from 7. So if you had something up around 14 or 15, that would be very, very basic. So this is it's kind of similar to that, right? This is very, very acidic. So something less than 1 is very, very acidic. All right, so we're going to just wrap it up and just close there. For homework, finish the other page here. So you have, I forget the numbers, what is it, 5 through 9. So just finish those up for homework. I'll see you guys again tomorrow, same time, same place. And if you guys have any questions, just ask me then. I see that we're only getting 8 people that are in the live stream. So hopefully everybody else will actually watch this and, do their homework. Hopefully we haven't lost anybody over spring break. So anyway, have a great rest of your day. I'm going to go ahead and close out unless you guys have any questions. Just a reminder, our test, I'm aiming for next Tuesday. If you guys have any problems with that, just tell me and we can adjust it a little bit. But I think Tuesday is going to work out pretty well for us. Just, make sure we don't forget everything that we studied before the break. So, see you guys.